Something is sitting in the deepest images ever captured by human technology. And for the last 3 years, it has been quietly breaking the rules of physics that scientists have trusted for nearly a century. The James Webb Space Telescope was built to look back in time to capture the faint light of galaxies that formed just after the Big Bang. But what it found out, there wasn't a confirmation of what we already knew. It was a series of objects so strange, so impossible according to our own models, that astronomers still don't fully agree on what they're even looking at. This is the story of the little red dots, and why some of the most respected astrophysicists on the planet are now saying JWST may have just shattered the standard model of how our universe was built. Let's start with what actually happened. When the James Webb Space Telescope began sending back its earliest deep-field images in the summer of 2022, astronomers noticed strange, compact, extremely red objects scattered across the ancient light it had captured. The first one was spotted and confirmed in 2023, cataloged as JWST 746, sitting at a redshift of 5.6, meaning its light had been traveling toward us since the universe was less than 1 billion years old. Then more began appearing. A survey using JWST's NIRCam instrument identified around 20 more of these same strange red sources, and researchers gave them a name that stuck: little red dots. Since then, astronomers have found dozens upon dozens more of them, and they still don't completely agree on what they actually are. Here's why that matters so much. According to the standard model of cosmology, the model every astrophysics textbook on Earth is built on, galaxies are supposed to form slowly. Small clumps of gas collapse under gravity. Stars ignite. Galaxies merge and grow over billions of years. It's a gradual, patient process. But these little red dots don't play by those rules at all. They're showing up in the deep, ancient light of the early universe, existing less than 1 billion years after the Big Bang. And yet they display exactly the kind of unusual brightness and compact structure you'd expect from something impossibly massive and impossibly fast-growing. Their light shows a distinctive V-shaped signature, bright in ultraviolet, bright again in optical wavelengths, but with a strange dip in between, unlike anything from a normal star-forming galaxy. In July 2024, astronomers found one of the most extreme examples yet, an object they nicknamed the Cliff, whose light had been traveling toward Earth for 11.9 billion years. Its spectrum contains such a dramatic, sudden feature that researchers said it earned its nickname purely from how the data looked on the graph, like falling off the edge of a cliff. Objects like this pushed scientists to a conclusion that sounded almost too strange to publish. What if these little red dots aren't galaxies at all in the traditional sense? What if we're looking at something that doesn't fit any existing category? That question led researchers down a path that has only gotten stranger. Throughout 2025 and into early 2026, multiple independent research teams began publishing evidence pointing toward a wild but increasingly credible explanation. These objects might be what scientists are now calling black hole stars, supermassive black holes in the early stages of the universe, feeding and growing at rates that current physics says should be impossible, all wrapped inside a dense, glowing cocoon of gas. In one case, a specific object designated Glimpse 1017-5 became one of the strongest pieces of evidence, yet that these strange red data dots are in fact ravenous, rapidly growing black holes disguised as something that looks almost like a star. But this raises a problem that cuts right to the foundation of modern cosmology. The standard model says supermassive black holes are supposed to build up slowly, growing from smaller, light seed black holes over enormous stretches of cosmic time, merging and feeding gradually across billions of years. But if these little red dots really are black holes that formed and grew this massive within the first several 100 million years after the Big Bang, then something in our fundamental understanding of how the early universe worked has to be wrong. Volker Braun, a professor of astronomy at the University of Texas at Austin and co-director of the Cosmic Frontier Center, put it about as plainly as a scientist can. Finding black holes this early in the universe goes directly against the standard model of how the universe builds structure. Whether you're talking about small pieces growing into big ones or something else entirely happening that we've never accounted for. By February 2026, a study published in the Astrophysical Journal proposed something even more specific and frankly more unsettling for anyone who trusted the old model. These little red dots may actually be what's called direct collapse black holes, meaning instead of forming gradually from smaller seeds, the slow way, massive clouds of primordial gas may have collapsed almost instantly into enormous black holes without going through any of the intermediate steps astrophysicists have relied on for decades. If that's true, it means the universe found a shortcut to building supermassive black holes that nobody predicted. A shortcut that may have been happening constantly in the earliest days of everything, hidden until a telescope powerful enough finally looked close enough to catch it in the act. And up by the middle of 2026, researchers weren't just finding a handful of these strange objects anymore. New theoretical work suggested that the little red dots astronomers have already cataloged represent only the brightest, most visible members of a much larger hidden population. Black holes going through the exact same violent, rule-breaking growth spurts, just too faint for even JWST to detect yet. Which means the odd little handful of anomalies that first confused scientists back in 2023 may actually represent something close to the norm for how the early universe behaved, not the exception. So, here's where we stand right now in the middle of 2026. The most powerful space telescope ever built has spent the last several years staring into the deepest, oldest light in the observable universe, and instead of simply confirming what physicists expected to find there, it has uncovered objects that shouldn't exist under the rules we've trusted for generations. And the deeper scientists dig into this mystery, the stranger and the more fundamental the implications become. The little red dots weren't the only anomaly. In fact, before scientists had even settled on what those strange objects were, JWST had already delivered a completely separate crisis to cosmology, one involving galaxies so massive, so early, and so mature that leading researchers openly said they shouldn't exist according to everything we thought we understood about how the universe builds itself. The story actually starts almost as soon as JWST opened its eyes on the cosmos. In 2023, a study led by EVO Lab identified a population of massive red galaxies that had formed roughly 600 million years after the Big Bang, and the numbers attached to them didn't make sense. These galaxies appeared to contain stellar masses exceeding 10 billion times the mass of our Sun, packed into a fraction of the time the Standard Model says should be required to build anything that large. Mike Boylan-Colchin, an astronomer at the University of Texas at Austin, published a follow-up study in Nature Astronomy analyzing 6 of the earliest and most massive galaxy candidates JWST had found, and his conclusion was blunt. These galaxies directly contradicted the reigning model of cosmology that virtually every astrophysicist on the planet works from, a model built on dark energy and cold dark matter, known as lambda-CDM. To understand why this caused such an uproar, you have to understand what that model actually predicts. According to lambda-CDM, galaxies build up gradually, small clumps merging into bigger ones over the course of hundreds of millions, even billions of years. For a galaxy to reach the kind of mass JWST was detecting in a universe that was only a few hundred million years old, essentially every scrap of available gas in that region would have needed to convert into stars almost instantly at close to 100% efficiency. Real galaxies, the ones we've studied for decades closer to home, typically convert somewhere around 10% of their available gas into stars. Finding galaxies operating at 10 times that efficiency in the earliest sliver of cosmic time felt less like an anomaly and more like a direct contradiction of the physics everyone had trusted. And it kept getting stranger. In November 2024, a research team published findings in Nature describing what they called red monsters, a population of massive early galaxies that appeared to have been forming stars far more efficiently than anything astronomers expected, growing dramatically faster than their later, more familiar counterparts. The researchers were careful to note that these red monsters didn't necessarily break the standard cosmological model outright, but they absolutely forced scientists back to the drawing board on how galaxy formation actually worked in those first few hundred million years. Something about the early universe allowed certain galaxies to grow up almost instantly. Nobody had a clean explanation for why. Then, in January 2024, Webb delivered something that added an entirely new layer of confusion. Astronomers led by Ben Forrest at the University of California, Davis, discovered a giant galaxy that, despite forming when the universe was still incredibly young, showed absolutely no signs of rotation. That kind of behavior is something typically only seen in enormous, extremely mature galaxies much closer to our own cosmic neighborhood, not in something that had barely had time to exist. It was one more piece of evidence suggesting that whatever process built these early structures, it wasn't following the patient, gradual timeline written into the textbooks. For nearly 3 years, this too big, too soon problem sat at the center of a genuine scientific crisis. Papers piled up. Some researchers proposed that early stars might have formed in an unusual way, producing more light per unit of mass than stars do today. Others suggested that bursts of extremely rapid star formation, followed by quiet periods, could make galaxies look artificially bright and massive when observed at just the right moment. Still others floated the idea that the standard model itself needed fundamental revision. This wasn't fringe speculation. This was published, peer-reviewed uncertainty coming from some of the most respected names in cosmology, essentially admitting that the deep past didn't look the way anyone's equations said it should. Then in May 2026, NASA's own science communications team published an update with a headline that surprised a lot of people who had been following the story for years. Webb finds early galaxies weren't too big for their britches after all. A study led by Kate Krobowski offered a compelling piece of the puzzle. A significant number of these apparently oversized early galaxies weren't quite what they seemed, because hidden supermassive black holes inside them were making the galaxies appear far brighter and more massive than their actual star content justified. Strip away the extra light contributed by these voracious, rapidly feeding black holes, and the remaining galaxy often fits much more comfortably within the predictions of the standard model. But here's the part that keeps this story from wrapping up in a neat little bow. That explanation doesn't cover every single anomaly. Some of these galaxies, even after accounting for black hole contamination, still appear too efficient, too massive. Could they be black holes wrapped in gas? They're intimately tied to this exact same mystery. The very objects solving one piece of the too massive, too early puzzle are themselves one of the strangest, least understood phenomena JWST has ever detected. In other words, untangling one anomaly led directly into the arms of another one. So, where does that leave modern cosmology in the middle of 2026? Somewhere between crisis and cautious relief. The most extreme version of the impossible galaxy problem, at least for some of these objects, may have found a partial explanation. But the underlying question that started this entire saga back in 2023 hasn't gone away. How did the early universe manage to build things this big, this bright, and this structured this fast? And why every attempt to resolve one mystery about the deep past seemed to uncover another one sitting right behind it? If the story of the little red dots and the impossibly massive early galaxies sounds like enough of a crisis for one telescope to cause, it turns out JWST has been quietly feeding into an even bigger fight. One that cuts straight to the question of how fast the entire universe is actually expanding right now, today. And as of just a few months ago, this fight isn't calming down. It's getting worse. Here's the problem in plain terms. Scientists have two completely independent ways of measuring how fast the universe is expanding, a number called the Hubble constant. The first method looks at the nearby universe, things like pulsating stars called Cepheids and exploding stars called Type I supernovae, building what's called a cosmic distance ladder. That method consistently gives an expansion rate of around 73 kilometers per second per megaparsec. The second method looks at the oldest light in existence, the cosmic microwave background, the leftover afterglow from when the universe was only 380,000 years old, and calculates what the expansion rate should be today based on the standard model of cosmology. That method gives a completely different number, around 67.4 kilometers per second per megaparsec. Those two numbers should match. They don't. And this disagreement, known as the Hubble tension, has been quietly simmering in the background of astrophysics for years. But here's where JWST comes back into the picture and where things get genuinely uncomfortable for cosmologists. Many scientists hoped that once James Webb came online with resolution roughly 4 times sharper than the aging Hubble Space Telescope, it would finally settle the argument. Some assumed JWST would reveal that the local measurements were contaminated by crowded, overlapping starlight, or interfering cosmic dust, artificially inflating that 73 number and making the disagreement disappear. That is not what happened. Between 2024 and 2025, behind the original local measurements, known as SH0ES, used JWST's superior imaging to reobserve the exact same Cepheid stars that had originally produced the higher expansion rate. The new JWST data matched the old Hubble data almost perfectly, effectively ruling out crowding or dust contamination as the explanation. The number held steady. Then, in April 2026, an international collaboration called the H0 Distance Network published what may be the most precise local measurement of the universe's expansion rate ever produced. Combining data from JWST and Hubble across multiple independent methods, Cepheids, red giant stars, and carbon stars all cross-checked against one another. Their result, 73.5 kilometers per second per MPC, with an uncertainty so small it essentially closed the door on simple measurement error as an explanation. Dan Skolnick, an astrophysicist at Duke University, had already stood up at a meeting of the American Astronomical Society back in January 2025 and said the quiet part out loud. This wasn't just a tension anymore. It was a crisis. And by early 2026, that sentiment had only spread. Some researchers pushed back, arguing certain teams weren't including all the available data, and that a middle ground answer was still possible. But the broader scientific consensus, as of the most recent reviews from late 2025 and into 2026, holds that this disagreement is not going away, and it is not a rounding error. Something is fundamentally unaccounted for in how we calculate the expansion of the cosmos. So what does this actually mean? If neither measurement is wrong, if it's not dust, not crowding, not some overlooked systematic error hiding in the data, then the only conclusion left standing is one that should make anyone pause. Our model of the universe, the same lambda CDM model that also predicted galaxies, shouldn't be able to grow as fast and as massive as JWST has shown they can in the early universe, might be missing something fundamental. Some physicists have proposed exotic solutions, an early form of dark energy that behaved differently in the first fraction of cosmic history. Extra unseen particles influencing the universe's very first moments. Or even modifications to gravity itself operating at scales we've never been able to directly test. And this is exactly why so many people are starting to connect the dots between these separate JWST mysteries. It's not just one anomaly sitting quietly in a corner of astrophysics. It's the impossibly massive early galaxies. It's the little red dots that keep turning out to be something stranger than ordinary galaxies. And now it's the expansion rate of the universe itself refusing to agree with itself, no matter how precisely you measure it. 3 separate lines of evidence. 3 separate teams of researchers working independently of each other, all converging on the same uncomfortable possibility. The standard model that has anchored cosmology for decades has cracks running through it. And JWST is the telescope finding every single one of them. Wendy Friedman, one of the most respected voices in this field, has publicly pushed back against, calling this a full repeated testing through independent teams checking each other's work through results getting harder and harder to explain. Await until eventually either the anomaly resolves itself or an entirely new piece of physics reveals itself. Right now, in the middle of 2026, we are sitting in exactly that uncomfortable, thrilling middle stage. Nobody knows yet which outcome we're heading toward. What we do know is this. The most powerful telescope ever built was designed to confirm our understanding of how the universe came to be. Instead, 3 years into its mission, it has handed cosmologists a stack of open questions that keep getting bigger, not smaller, the closer scientists look. So, where does all of this actually leave us in the middle of 2026 staring at a universe that seems less certain the more we look at it? Let's put the entire picture together, because when you step back and look at these 3 mysteries side by side, the pattern becomes almost impossible to ignore. First, there are the little red dots. Objects discovered in 2023 that turned out to be some of the strangest things JWST has ever photographed, now increasingly understood to be supermassive black holes forming and feeding at speeds that shouldn't be physically possible this early in cosmic history. Through a process called direct collapse, that may be rewriting how we think black holes are born in the first place. Second, there are the impossibly massive early galaxies, objects so bright and so mature, just a few 100 million years after the Big Bang that they initially appeared to directly violate the standard model of cosmology. An anomaly that's only been partially explained with genuine mystery, still sitting unresolved as of NASA's own research updates from earlier this year. And third, there's the Hubble tension, a disagreement over the expansion rate of the entire universe that JWST was supposed to help settle and instead has only made harder to explain away, confirmed as recently as April 2026 by one of the most precise measurements ever taken. 3 separate investigations, 3 separate teams of scientists, 3 completely different corners of astrophysics, and all 3 keep circling back to the exact same uncomfortable conclusion. The standard model of cosmology, the framework that has guided our understanding of the universe for decades, might not be complete. It might not even be close. Now, here's where I want to be honest with you because this is important. Nobody serious in this field is claiming the universe doesn't exist the way we thought or that reality itself is collapsing. That's not what's happening here, and any version of this story that tells you otherwise is exaggerating for clicks. What is actually happening is something arguably more exciting because it's real and it's happening in real time in papers being published this year, not in speculation. Scientists are watching the most trusted model in modern physics get stress-tested by better data than we've ever had access to before, and in multiple places that model is showing genuine strength. That's not the end of physics. That's how physics has always moved forward through the uncomfortable process of finding exactly where our best ideas stop matching what we actually observe. And this story isn't close to finished. Right now, JWST is deep into its ongoing observation cycles, continuing to hunt for more of these strange early objects, more little red dots, more impossibly massive early galaxies, more data points that will either resolve these tensions or deepen them further. On top of that, an entirely new tool is about to enter the picture, NASA's Nancy Grace Roman Space Telescope, expected to begin science operations in the coming years, is being built specifically to survey enormous swaths of the sky, potentially identifying over 1,000 new gravitationally lensed systems that could provide independent checks on the Hubble tension from angles we've never had access to before. The European Space Agency's Euclid mission is also expected to release major new results that could offer yet another independent perspective on the same expansion rate puzzle. In other words, within the next few years, we may finally get the additional data needed to figure out whether this is new physics or something more mundane we simply haven't spotted yet. But right now, today, in 2026, the honest answer is that nobody knows. And that uncertainty is exactly what makes this such a genuinely remarkable moment to be paying attention to space science. We are living through a period where one of the most powerful scientific instruments humanity has ever built keeps returning data that our own equations can't fully explain. Not once, not in one isolated case that can be waved away, but across 3 separate independent lines of evidence, all pointing toward the same conclusion. There's something about the structure and history of our universe that we still don't understand. So, here's what I want to leave you with. If the standard model of cosmology really does need to be rewritten, even partially, it means every textbook description of how the universe formed, every diagram of galaxies slowly building up over billions of patient years, may need an asterisk next to it in the years ahead. It means the black holes powering those strange little red dots might represent an entirely new chapter of physics we're only beginning to write. And it means the very rate at which our universe is expanding right now, the number that determines everything from the age of the cosmos to its ultimate fate, is still genuinely up for debate among the smartest people studying it. What do you think is actually going on here? Do you think these anomalies will eventually get folded neatly into the models we already trust the same way scientists partially resolved the too massive, too soon galaxy problem earlier this year? Or do you think JWST has stumbled onto something that's going to force an entirely new era of physics, one none of us can fully predict yet? Let me know what you think in the comments below. I read every single one of them. And if this story genuinely made you see the universe a little differently today, make sure you're subscribed because this saga is nowhere near over. JWST has years of observing time left. Roman and Euclid are coming. And if the last 3 years are any indication, The next discovery that shakes up everything we thought we understood might already be sitting in a data set somewhere, just waiting for someone to notice it.